Hi guys, in this video I will talk about quantum numbers in L, ML, MS. In L, ML, MS. So N stands for energy level. L, it stands for the pathway of electrons or the density of electrons in an atom that in 90% time we can exactly describe where it is in an atom. And it has some shapes like a sphere, a dumbbell, or a clover leaf, that is. Because we talk about number, so we need to change this one to a number like 0, 1, 2. I mean this is S orbital, this is P orbital, this is G orbital, and F orbital, G orbital. So we need to change some letter to a number like 0, 1, 2, 3, 4, and that's value of L. It can be 0, 1, 2, 3, or 4. So for some elements in group 1A, 2A, or 3A, 4A, we have N is the parent number. But for transition metal, we have N is equal to the parent number minus 1. This one. N is equal to the parent number minus 1. Because N is the energy level. With transition metal, it has a different kind of energy level, like we have graph like this one. We know that it's 1s here, 2s here, 2p here, 3s here, 3d here, 4s here, and 3d here. So for transition metal, the 3d orbital, it has higher energy than 4s. So n is 4 minus 1, not 4, but it's 3. So n is 3. For example, we have an element in this is here, and it's a transition metal, so n is 4 minus 1, so n is 3. 3D here, 3D, 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 and 3D. It's not 4D. And this one here is 40, 40, 40, 40, 40, 40, 40. And that's L and N. We talk about ML. ML is orientation. Here, orientation of orbital. So with a sphere orbital here, we see we don't know exactly the orientation of a sphere, so it's 0 ml with a sphere orbital. L is 0. L is equal to 0. It means we talk about s orbital, and we talk about p orbital is a dumbbell shaped. This one, with this one, we have some directions like x, y, and z. So we talk about p orbital. P orbital, it means L is equal to 1, and we have three directions x, y, and z of p orbital, and stand for px, py, and pz. We talk about p orbital here. This is a p block. Here, p block. So we need to know px, py, and pz, where is. And in general way, we have this input. This one is px, py, pz, and px, py, and pz. We cannot use xez in number, so we need to change to a number like -1, 0, 1. That means px, py, and pz. So it will be -1, 0, 1, -1 again, 0, 1 again. So when you have an element like, for example, let's see, carbon, it belongs to group 5, and we know carbon here. So ml of carbon is 0. I think it's an easy way to remember with a table like this one, and you can guess ml is how much. How about d orbital? D orbital has 5 orientations with the z square, the xy, the yz, and the xx, and the x square, or the e square. So it's d here, d block. Again, we have a general way to know where the z square or the x, y, the yz are, because this one is -2, this one -1, 0, 1, and 2. So again, we fill in the blank like -2, -1, 0, 1, 2. And again, 0, 2, -2, -1, 0, 1, 2. So if you have an element in this position, we have directly a number of ml is 1 here, and that's for transition method. And why do we have -2 from the beginning? Because we have L is 2. So we can assume that it begins from -2. That is one a way to remember. I summarized for that, so I need to find a way to remember like L is 2, so it begins from -2 to -1, 0 and 1 and 2. And how about F orbital? F orbital has let's see orbital here. F orbital it stands for 3, and we begin from -3, -2, -1, 0, 1, 2, 3, and again -3, -2, -1, 0, 1, 2, 3, and again if you have an element in this position, we have ML will be 2, and that's it. And finally, we talk about MS. I need to change the color. MS. For MS, we have two values like MS. We have two values, positive 1/2 and -1/2. Because I think okay, I need to draw here. We have an electron here, and the spin of electron, here, and this spin here, this spin here. When we have two electrons in an orbital like this, we call MS is -1/2, and if we have one electron here, we call is positive 1/2, and that's just a simple number to know the spin and how many electrons in orbital. I will come back with some example to demonstrate the theory, the lesson, to understand